Hello, am I audible? Hello, hello. Can anyone confirm? Am I audible?
Yes, sir.
Okay, thank you. Is my screen visible?
Yes.
Okay, thank you. So good afternoon, everyone. Welcome to this NPTEL live session, week 4 for this course, Introduction to Machine Learning. My name is Ayan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So in this live session, we will discuss some practice problems on this week's topics, which are artificial neural networks and parameter estimation. So these are the two topics that are being taught in this week, that is week 5 that is being run right now for this course. So first I will discuss some practice problems on these topics, and after that I will try to answer your questions and doubts if you have any. So after that I will try to take your questions and I will try to answer those questions and queries. So Deepak has asked, can you please tell me when I will be allowed to ask doubts? Yeah, I would prefer to take the questions and doubts after the problem solving session, but you can also ask your doubts right now if you want. Deepak, are you present in the session?
Hello, sir.
Yes.
I had some doubts regarding SVM, so it will be better in interest of everyone, so that I can ask those doubts at the end of the session.
Okay. Yeah, you can ask it at the end of the session also.
Thank you.
So let's start this session. One thing to note is that this is a 2-hour session from 3 p.m. to 5 p.m. but Google Meet doesn't allow meetings over 1 hour. So after the first hour, that is from 3 p.m. to 4 p.m., I will create a new meeting link and I will share the meeting link in this meetings chat. And so at 4 p.m. you have to join the new meeting link, otherwise this meeting will be ended automatically. So I will notify all of you that the 1 hour is done, and I will share the meeting link in this meeting chat. So please make sure that you click that meeting link and then end this meeting, or leave this meeting, otherwise this meetings chat will be lost once this meeting is ended. So I will tell all of you when the first hour is done, and I will create the new meeting link and share. So first we will discuss the practice problems on artificial neural networks and parameter estimation. So this is the first question. So the first question is, if the step size in gradient descent is too large, what can happen? So there are 4 options. So if the step size in gradient descent is too large, what can happen? Overfitting, the model will not converge, we can reach maxima instead of minima, none of the above. So there are 4 options. So if we increase if we take the step size to be very large, then what might happen out of these 4? You can write your answers in the chat. So Akanksha Joshi has written B, which is the model will not converge. Okay. So any other answers? Deepak has written model will converge depending on error rate or stopping criteria. Anyone else? What can happen out of these 4 options? So the correct answer here should be B, the model will not converge. So if the step size is very high, so it would jump from one point to another, a very large jumps will be there. So it is possible that the model will not be able to converge to the minima. So it might converge, but it can happen that it will not converge, because step size, we don't take the step size to be very high, because if the step size is very high, we will get huge jumps, and in that case the model will basically oscillate between similar values. So we don't want that. So we want the step size to be moderate, not too small, not too large, so that it gives the gradient descent algorithm enough scope to converge to minima. So B would be the right answer here. Model will not converge. So Deepak has written model will converge depending on error rate. Yeah, model might converge, but if the step size is too large, it is expected that model will not converge, because big step size is not very really preferred in case of gradient descent. The huge jumps will be there, and for smoother transitions we prefer this model size to be small. So B will be the right answer. The model will not converge in this case. So this is the second question. So this XOR table has been given. The XOR logic table is given. A truth table is given. for XOR gate. I hope most of you are familiar with XOR gate, and also this the XOR example has been taught in the class as well in week 5 content under the artificial neural networks. This XOR has been covered, how neural networks can be used for XOR. So the XOR truth table is given. So generally we know that XOR is not linearly, these points are not linearly separable, because if we plot the XOR table, this is x1, this is x2, so the 4 points would be minus 1 minus 1. So if this is minus 1, so here would be 1 point, minus 1 point, 1 minus 1, there would be another point, here would be 1 point, here would be another point. So you can see that the plus 1 points are diagonal to each other and minus 1 points are diagonal to each other. So these set of 4 points are not linearly separable. You can easily see from here. You cannot draw a single straight line that would separate these 4 points, the positive and negative points. So transformation is required on these two features, x1 and x2. So we need to transform x1 and x2 to some other dimensions, other new features, so that in the new feature domain the data points are linearly separable. So what can be that transformation? Which of these following transformations can work? The 4 options are given, x1 dash and x2 dash. These two new features are created. So these two, x1 dash and x2 dash, these are the new features that are created. So which of these transformations would work? So you have to find out that, so that the points are linearly separable. So is the question clear here? Okay, so what will be the correct transformation? Multiple answers may be correct here. So the Vazralu has written C. C is x1 dash equals x1 x2, x2 dash equals minus x1 x2. Okay, so you have to check all 4, because multiple answers might be correct in this case. Any other answers? Has anyone computed all these x1 dash and x2 dash values and then checked it? Vijay has written A. So Vijay, you have written A, but if you just A is x1 dash equals x1 square and x2 dash equals x2 square. So just squaring either plus 1 or minus 1 gives 1. So all the points become 1 comma 1, isn't it?
Yes, all are on one side.
So all the points should become 1 comma 1. So it is no way separable. So y value is not transformed here. The x1 and x2 values are transformed. So all the x1 dash and x2 dash values are 1 comma 1 in case of A. Yes, Akanksha has written A would cause all points to overlap. Yes, all the points would become 1 comma 1 with transformation of A. So A is certainly not the correct answer here. Any other answers? So in this case, if you compute all the 4 transformations, you will find that only C and D are correct answers. A and B will not be correct. So what was C? C was x1 dash equals x1 x2 and x2 dash equals yes, x2 dash equals minus x1 x2. So that way you calculate all those x1 dash x2 dash values. So the points you get from the C transformation is 1 minus 1, 1 minus 1, minus 1 1, minus 1 1, 1 minus 1. And if you plot these 4 points, you will see that these are linearly separable, because so first point is 1 minus 1, so 1 and minus 1, here is 1 negative point, then minus 1 1, so minus 1 1, here is 1 positive point, then minus 1 1 again, so 1 more positive point here only. So there are 2 points here, so let me draw 1 plus 1 here. So these two points are overlapped, and 1 minus 1 minus 1, so this point is also here, so these 2 points are also overlapped. Sorry. Yes, so you can see that both the positive points are here and both the negative points are here, so you can easily draw a straight line that will separate these two set of points. So this way you have to do. So C, using transformation C, these two sets of points are linearly separable. And similarly, what was the D was x1 minus x2 whole square and x1 plus x2 whole square. So if you do the transformation, this is the truth table that you get: 0 4 4 0 4 0 0 4. So if you again draw it, so 0 4 somewhere here, so this is 1 minus 1 point, 4 0, so here is 1 plus 1 point, another plus 1 point here only at the same place, and 0 4 1 minus 1 point, another point. So both the plus 1 points are here and both the minus 1 points are here, so again these 0 points are linearly separable using any straight line like this. So this way you have to check for all transformations whether the new sets of points are linearly separable or not. So you have to compute x1 dash and x2 dash for all 4 cases, and you have to check whether points are linearly separable or not. And so A, I already told that it is not possible because all the 4 points are 1 comma 1 in this case. And in case of B also, if you compute, you will see that it is not linearly separable. You can check by computing this truth table for transformation B. So C and D, these two are the right answers. Deepak has asked, how do we decide y after transformation? Y remains the same. So y is what it was already given. Y doesn't change here. X1 and x2 values are transformed to x1 dash and x2 dash. So y remains whatever it was minus 1 1 minus 1 previously also. So minus 1 1 1 minus 1, this was the y values, and here also the y value remains the same, minus 1 1 minus 1. So y is not changing, only you have to transform the x1 x2 to x1 dash and x2 dash. Is there any other doubts in this? Anyone? Okay. So this is the third question. What is the effect of using activation function fx equals x for hidden layers in an ANN? So I hope all of you know the the action of effect activation function in case of neural networks. So the activation function that here we are using is fx equals x. This is a linear activation function. Basically this doesn't change, doesn't make any change to the output of any hidden layers. Fx equals x. So this is the activation function that we're using in the hidden layers. So what will be the effect of using this activation function? We generally don't use this as an activation function, but if we use this, what is the effect? So option A is no effect. It is as good as any other activation function like sigmoid, tan A. So these are the general activation functions that we use. Sigmoid, tan A, this, or softmax, these are. Option B is the ANN is equivalent to doing multi-output linear regression. C is backpropagation will not work. D, we can model highly complex nonlinear functions. So what is the effect of using the activation functions out of these four options? Akanksha Joshi has written B, which is the ANN is equivalent to doing multi-output linear regression. Okay. Anyone else? Krishna has written A, Vijay has written B. So here the answer is B, which is ANN is equivalent to doing multi-output linear regression. So why is that? So fx equals x. So if you just do the operations on this operation on hidden layers, you will see that it doesn't make any difference of using hidden layers at all. It simply becomes like if the neural network is like this and you have multiple hidden layers and then some output layer. So these two are hidden layers, and if we simply apply this linear activation function fx equals x in these two hidden layers, so this is equivalent to just not having these hidden layers at all. So this is the input and this is the output layer. So it is equivalent to having no hidden layer at all. So fx equals x doesn't is not able to include non-linearity into the neural network structure. So this simply becomes linear regression with multiple outputs. If there are multiple output units in the output layer for the neural network, it will have it will be a multi-output linear regression. So option A is not correct, that it has no effect. So it would have effect. The effect is that the ANN is equivalent to doing multi-output linear regression. So that's why we try to use non-linear activation functions like sigmoid, tan H, all these activation functions or even ReLU is one of the activation functions, regularized linear unit. Deepak, can you please write mathematical equation for C? It would be very big expression, like we have to take care of all the parameters and the hidden unit activation values. So you can try it out with only one hidden variable yourself, and you'll be able to see that this linear, using this linear activation function doesn't make any difference. So it is not able to bring non-linearity in the artificial neural network, and if there is we are not able to include non-linearity, then it is of no use. It is same as linear regression only. So you can work that out. Like it would be difficult for me to go through the whole maths here, but it can easily be shown that it simply is a the multi-output linear regression. So A is the right option here. Sorry, B is the right option here. That it is multi-output linear regression. Fourth question. Which of the following functions can be used on the last layer of the ANN for classification? There are four options: softmax, sigmoid, tanh, and linear. So which of these following activation functions can we use on the last layer, that is the output layer, for classification? Akanksha has written A, softmax. Okay, so multiple correct answers here, so it can have multiple correct answers. Deepak has written ABC, Akanksha has also written ABC. So no one has written D yet, which is linear. Any other answers? The correct answer here would be A, B, C. So both of you have written correct answers. Linear is the only option which is not right here. So I have already shown that linear is fx equals x, and in case of classification, obviously you cannot use fx equals x. In case of regression, you might be able to use fx equals x at the output layer, because if in case of regression the output can be continuous value and anything from minus infinity to infinity, so linear is fine in that case. But in case of classification, we have specific classes, and linear cannot be used in that case, because you have to output a specific class in the output layer, so linear cannot be used. Softmax, sigmoid, tanh, all these three can be used. Softmax is mainly used when we have multiple classes, more than 2 classes in the classification task. In that case, softmax is preferred, and sigmoid is used generally when we have only 2 classes, 0 or 1. So in that case, there is only one output layer, and on that only one output unit, only one output unit is there, and you apply sigmoid on that for classification. And tanh is also similar to sigmoid, but the range for tanh is -1 to +1. In case of sigmoid, it's 0 to 1. So sigmoid is from 0 to 1, and tanh is -1 to +1. So tanh is also used when there are only 2 output classes, and so you will have only one output unit in the output layer, and you can apply sigmoid or tanh. Only the range changes for sigmoid and tanh. And softmax is basically an extension of the sigmoid for multi-class outputs, where you have more than 2 classes in the output, you use softmax. So A, B, C, these are the 3 right answers. Question 5. So a statement is given and the reason is given, and you have to find out whether the statement is true or and or the reason is true. The statement is the threshold function cannot be used as activation function for hidden layers, and the reason for that is the threshold functions do not introduce non-linearity. So whether statement is correct or not, you have to first find out, and then you have to find out whether the reason for this statement is this or not. A statement is threshold function cannot be used as activation function for hidden layers. So is the statement true or false? That threshold function cannot be used as activation function for hidden layers. Can threshold functions be used as activation function for hidden layers? Anyone? So threshold function looks something like this. Like this. So this red curve is the threshold function. So when it's greater than 0, so this is x and this is y. Let's say when x is greater than 0, then it's plus 1, and when it's x is less than 0, it is 0. Sometimes it is also taken as minus 1. So the when x is greater than 0, it's plus 1, otherwise it's 0. When x is negative, negative, then it's 0. So this is how the threshold function looks. So in case of neural networks, you might have noticed that you have to use the in case of gradient descent, you have to calculate the gradient values for each of the hidden units and hidden layers. So in that case, if you use this threshold function, so this threshold function is not differentiable. It is a non-differentiable function because of this hinge here. So it certainly jumps from 0 to 1. So this threshold function is not a differentiable function, and if it is not differentiable, you cannot use it in backpropagation algorithm, because you have to find out the gradient values for every layer, every hidden layer. So this cannot be used as activation function for hidden layers. And so statement is true that it cannot be used as activation function for hidden layers. Now, is this reason correct for this, that threshold functions do not introduce non-linearity? So is this the right reason for this? So Akanksha Joshi has written no. So this is right, that this reason is not right. This reason is false, that threshold functions do not introduce non-linearity. Threshold function is certainly non-linear. You can see that this is 0 and then at some point it goes to +1. So a threshold function is certainly non-linear. It is not a straight line. But why is it not used as activation functions? Is because it's non-differentiability. So you cannot differentiate this function so you cannot use it in backpropagation for gradient calculations. So the correct reason would be that threshold functions are not differentiable. That's why the threshold functions are not used as activation functions. So option A is correct. The statement is true, but the reason is false. So threshold functions cannot be used as activation functions for hidden layers, which is true, but the reason that threshold functions do not introduce non-linearity, this is false. So the reason would be threshold functions are not differentiable, that's why they cannot be used. So A is the right answer. Let's go to the sixth problem here. We use several techniques to ensure the weights of neural network are small, such as random initialization around 0 or regularization. So these are the different techniques that we use so that the weights are small. What conclusion can we draw if the weights of A and N are high? So the question is, what conclusion can we draw if the weights of our A and N are high? 4 options. Model have overfitted. B, it was initialized incorrectly. C, at least one of A or B, and D, none of the above. So if the weights are high, if we notice that weights of a neural network is high, weights of a neural network are high, then what is the conclusion out of these 4? That whether model has overfitted or it is initialized incorrectly. Deepak says A, model has overfitted. Any other answers? Akanksha Joshi has written C. So at least one of A or B, there is either model has overfitted or it was initialized incorrectly. So here the overfitting may happen because of very high values of the weights, but it is not always the case that the weights are high because model has overfitted, which is that conclusion is not right. There can be many other reasons, and it was initialized incorrectly, that might not also be the case. You cannot conclude surely that it was initialized incorrectly or the model has overfitted. So the correct answer here would be D, none of the above. So overfitting might happen because of high values of the weights, but it is not a sure shot conclusion. So you cannot surely tell 100% sure that model has overfitted. The overfitting is the cause of this. or the initialization has been incorrect, that's why the weights are high. You cannot conclude this surely. So the option here would be, there can be many reasons for the weights to be very high, like it can be because of the loss function that you have chosen, or the gradient descent. There are many variants of gradient descent algorithm, so what kind of gradient descent algorithm you have chosen, or even the data that you are using for training, that might also be the cause for that. So you cannot surely say that A or B are the conclusions from this. So option, the correct answer would be none of the above. D would be the correct answer. This is the seventh question. On different initializations of your neural network, you get significantly different values of loss. What could be the reason for this? So if you initialize the neural networks in a different way, you get different values of loss after training. So you if you randomly initialize the neural network weights and train it on the same data, you will get different loss value different times because of this different initializations. And what is the reason for that? Four options: overfitting, some problem in the architecture, incorrect activation function, multiple local minima. So why what could be the reason for having different loss values for different initializations of the weights? Akanksha has written D, multiple local minima. Okay. Any other answers, sir? Deepak has written C, incorrect activation function. So correct answer here is D, multiple local minima. So if you have followed the video lectures, there sir has already shown that the loss function for neural networks has many ups and downs. So it's like there are many maximas and minima values. So it might happen in case of neural networks that because of different initialization of the weights after training, you end up in a different local minimum every time. So loss function, if we just plot it in one dimension, this is the loss function. This might look like this. Sorry, let me draw it like this. So this is the actual global minima, but there are many other local minima like this one here. So all these are local minima points. These are so the if you initialize it in different ways, it might happen that the weight values have reached any of the other any of these local minima points here or here. So it might get stuck in those local minima points. So it might not be able to reach the global minima. Here the correct answer would be multiple local minima, that because of multiple local minima points in the loss function, because of different initializations you get different values of loss on different runs. So D, multiple local minima would be the correct answer, this one. So I have started this meeting for almost 1 hour, so the meeting would be over in 5 minutes automatically, so I have to create a new meeting link. I am creating a okay, Deepak has written, why don't we design convex functions? No, so there are so many in case of neural networks, there are so many parameters, basically weights from one layer to other. So there are so many weights or parameters that it's very difficult to design a completely convex function, loss function for neural network. So whatever loss function, they generally assume loss functions that we take are we take the cross entropy loss for classification, or the mean squared error loss in case of regression. These are the loss functions that we use, and as there are so many weights or parameters that the loss function itself becomes non-convex. So there are multiple minima values, there might be one or more global minima values, but because of initialization the neural network might never be able to reach the global minima. So that might happen, and this happens because of these local minima points, that you might get stuck in the local minima points, and there are different methods to overcome those local minima points and start going towards the global minima points. There are different variants of gradient descent algorithms using momentums, and some other concepts are there. Using those you can get rid of those local minima points, but this is a known observation on neural networks, that there are multiple minima points, so you might get stuck in a local minima. So I am creating a new meeting link, and I am sharing it in the meetings chat for this second hour from. So I have shared the new meeting link in the chat, so please join this new meeting link now and leave this meeting. First copy that link or click that link and then leave this meeting, otherwise you will lose this meeting and this link. And I will join in a few minutes after all of you have joined the new meeting. So I'll be waiting for a few minutes here so that all of you join this new meeting. Am I audible? Hello? Am I audible? Is my screen visible?
Yes, sir.
Okay, thank you. Question 7 is done. So D, local, multiple local minimum, that would be the right answer. This is the 8th question. The likelihood function L theta given x is given by 4 options: P theta given x, P x given theta, P x into P theta, and P theta divided by P x. So which of these 4 options is likelihood function L theta given x? Akanksha says B, P x given theta. Any other answers in this? So here the correct answer is B, Px given theta. Akanksha has written that. So this is what we call the likelihood function L theta given x. So you might have already seen this in logistic regression and also in case of parameter estimation. So this likelihood has been shown there, that the L theta given x is nothing but Px given theta, and we try to maximize this in case of maximum likelihood estimation. We try to maximize this thing. So in case of MLE, we try to find out this theta MLE, which is arc max of Px given theta for theta. So this is what we try to do for maximum likelihood estimate. So this is the likelihood function. So B is the right answer, Px given theta. This is the 9th question. This is on the parameter estimation. You are trying to estimate the probability of raining today using maximum likelihood estimation. So given that in n days it rained nr times, what is the probability of it raining today? So you have to use maximum likelihood estimation to find out the probability of raining today. So given that in n days it has rained nr times, so the options are nr by n, nr by nr plus n, n by nr plus n, and d none of the above. Darshan has written C, which is n by nr plus n. Any other answers here? Akanksha has written B. B, which is NR by NR plus N. So we have to use maximum likelihood estimate for finding out this probability. So if you, in general, if you try to find out the probability of raining, just given these facts that out of n days, nr times it has rained. So in that case, what would be the probability without using the maximum likelihood estimation or any other kind of estimation? If you are just given that in n days it has rained nr times, what is the probability of raining in that case? So in that case, it is simply nr by n, isn't it? If we are not using any kind of estimation, just we are using the theory of probability. If out of n days nr times it has rained, so nr by n. But if we use maximum likelihood, will it be the same or will it be something else? So we have to find out that. So this would be similar to the coin tossing example given in the class also, the Bernoulli for the Bernoulli distribution that has been shown there. So if we do the similar things here, so let's consider this x as the random variable. So x is 1 for raining, and it is 0 for not raining. So probability of x equals, so let's consider for ith day. So xi is the random variable for raining on ith day. So xi equals small xi. This is if we let's consider the parameter here is theta. Theta is nothing but the probability of raining on a given day. So this follows Bernoulli distribution, which we can write it like this, isn't it? This was shown in the class. Theta to the power xi 1 minus theta to the power 1 minus xi. So if the xi is 1, then so for if xi equals 1, then this probability is just theta, and if xi is 0, then this probability is 1 minus theta. So and theta is the probability of raining. So this is all right. So we can write it like this. This is a compact form of writing the same thing. So this is the probability. This is coming from the Bernoulli distribution. Now so for probability of x given theta, where x is so x is x1 x2 up to xn. So this is set of all n days. In that case, this is probability of pxi xi equals small xi given theta, product of this I equals 1 to n, and this will be what? So we have to multiply all these theta to the power xi 1 minus theta to the power 1 minus xi values. So if we calculate this, it would we have to take the log here also. So we will take the log of this. So log of px given theta, because we want to do it using log likelihood. So this will be summation of log of pxi equals xi given theta. So it would become as n. So it would become xi log theta summation over this plus 1 minus xi log 1 minus theta for all the days. So summation over I equals 1 to n. So this is what we will get. Now we have to take the derivative of this expression with respect to theta, because we are using maximum likelihood estimation. So we will take the derivative of this with respect to theta, and I will not do the rest of the part. But if you take the derivative of this with respect to theta, that the result that comes out is that you will get theta equals summation xi divided by n. You will get summation xi I equals 1 to n divided by n, and this summation this summation xi I equals 1 to n, this is nothing but the total number of days it has rained. So this numerator is nothing but nr and denominator is n. So you will get that theta is nr by n. So you have to take this derivative of this log likelihood with respect to theta. So this is the main thing here, and you will end up with this value of theta, summation over of xi over I equals 1 to n divided by n, and so this numerator is nothing but nr, and the number of days it has rained. So A is the right answer. So even without using maximum likelihood estimation, we would have answered it nr by n, and also using likelihood estimation the result is the same. It's still nr by n. Option A is the right answer. So option A is the right answer, and it follows the coin example discussed in the class. So you can go and check that question problem out in the video lectures. You will find out the similar computations would be done here also. So is there any confusion in this? Is it all right, this calculation? Okay. So now the 10th question, choose the correct statement, multiple may be correct. 4 options. So MLE, which is maximum likelihood estimation, is a special case of MAP, which is maximum a posteriori estimation, when prior is a uniform distribution. So MLE is a special case of MAP when prior is a uniform distribution. MLE acts as a regularization for MAP. MLE is a special case of MAP when prior is a beta distribution, and MAP acts as a regularization for MLE. So this question is based on MLE and MAP. See the relation between MLE and MAP. So which of these 4 options can be correct? Multiple answers might be correct here. So I hope all of you are aware of MLE and MAP, and what are the definitions of MLE and MAP. So based on that you have to find out. So anyone has any answers here? So MLE, how do we define MLE? So in MLE we try to find out this theta MLE, which is I have already shown it in the previous slide. Argmax P x given theta. So P x given theta is the likelihood, so we are maximizing this likelihood. And similarly, how do we define MAP? So which is maximum a posteriori estimation. So here we try to find out argmax of P theta given x, which is the a posterior probability or posterior probability. and this is same as argmax p x given theta into p theta. So these two are very similar, these two argmax functions, only this p theta is the extra term here in case of MAP. So now can anyone answer? So this argmax p x given theta is present in both the formulations of MLE and MAP. Only this p theta part is different in case of MAP, which is not present in MLE. Deepak has written A and B. MLE is a special case of MAP where prior is a uniform distribution, and B is MLE acts as regularization for MAP. Anyone else? So the first option is certainly correct, that MLA is a special case of MAP when prior is a uniform distribution. So if this p theta, if this value is this is a uniform distribution, that is p theta is a constant, so it has same value for every theta, so we don't have to put it in inside of this argmax. So then MAP becomes the theta MAP becomes theta MLE. So if the p theta is constant, then MLE becomes MAP only. MAP becomes MLE only. So MLE is certainly a special case of MAP when prior is uniform distribution. But B option is not correct. So D option is correct here. MAP acts as regularization for MLE. So by introducing this p theta, we are applying this regularization on in case of MAP, which is not present in MLE. So we can choose p theta to be in such a way that values of theta, the theta values are closer to 0, which is what we do in case of regularization. So we can use a skewed we can use p theta as a Gaussian distribution around the mean equals 0. In that way we can regularize the values of this theta in such a way that the theta values are very small. So MAP acts as regularization for MLE. So this by introducing this p theta here inside this argmax, we are introducing the regularization. So option D would be correct. So A and D, these are the two correct answers here. So B is not right, that MLE acts as regularization. MAP acts as regularization for MLE. So D is the correct answer. So these are the two correct answers, A and D. Now let's go to the 11th question. So a graphical representation of a function is given here. You can see that x, y, z, these are the three inputs here, and then we have one neuron Q which simply adds x and y values, and then we have another neuron F which multiplies Q with z. So this is like a computation graph you can think of. And the values of x, y, z are given. X is -2, y is 5, and z is -4. So in that way, x plus q is x plus y, it becomes 3, and if q into z, so it becomes 3 into -4, so it's -12. So now what you have to do is that you have to find out the gradient of f with respect to x, y, and z. So this is a computation graph, and the final value f is calculated as -12. Now you have to find out the gradient of f with respect to x, y, and z. So you have to find out del f del x, del f del y, del f del z. What are the values of these three gradients? So these are partial derivatives, obviously, because f is a function of all three variables. So you have to find out the partial, you have to compute the partial derivatives and find out the values. -4 and 3. Okay, Deepak has written -4 and 3. Any other answers? Anyone else? Has anyone computed this? This is not very difficult. This is a fairly simple calculation. Just you have to uh, understand how these gradient calculations work. Okay, so yeah, Deepak has written the correct answer. The correct answer is -4 3. So how do you compute that? So if we have already seen that f is q into z and q was x plus y, so x plus y into z. So this was f. Now you one by one you have to find out these partial derivatives. Del f del x, first compute del f del x. So if you compute del f del x, you will see that it is just z. And what was the value of z? Z was -4. Similarly, del f del y, this is just the same. This is also z, because x is constant in case of del f del y. So this is it. This is also -4. And finally, del f del z. So this is z. So this is x plus y. X plus y was 3. So -4 3. So this is the correct answer. Is it all right? Has everyone understood this? Any doubt in this question? So just you have to express f as a function of x, y and z, and then you have to compute these partial derivative values with respect to x, y and z respectively. 12th question, this is the last question. In training a neural network, we notice that the loss does not decrease in first few starting epochs. What is the reason for this? So for the first few iterations, the training the loss is not decreasing, which we want to decrease. So what could be the reason? 4 options are given. The learning rate is low, regularization parameter is high, stuck at the local minima. All of these could be the reason. All these 3 could be the reason. So which of these 4 options are correct here? So loss value is not decreasing for the first few epochs. Anyone? So loss is not decreasing, so learning rate is low, so this can be one reason. If learning rate is very low, it would not make any update to the weights and also to the loss. It might happen that the learning rate is so low that it is not able to affect the outcome at all. Regularization parameter is high. If the regularization parameter is very high, then the gradient descent is trying to trying to reduce the regularization much more than it is trying to reduce the actual objective function. It might happen the regularization parameter is dominating the actual loss function. So because of that, it is not learning at all. It is not able to reduce the loss value. It is just trying to make the parameters closer to zero because of this high regularization parameter. So this can also be one reason. And stuck at a local minimum, so this is always a possibility that it is stuck to a local minima and it is not able to get out of it. So for few epochs it is trying to find out the gradients, but it is not able to find any path of going out of it, so it is stuck there, and loss is not decreasing because of that. So basically all of these four could be the reasons. So all of these could be the reasons, all of these three could be the reasons. So D is the right answer. So option D could be the right answer. The problem can occur due to any of the reasons above. So these are the questions that I wanted to discuss today. So if you have any doubts regarding any of these questions that I discussed now, you can ask me, or if you have any other doubts or questions, you can ask me now. Does anyone have any doubts or questions? Yeah, Deepak, you have pasted some link.
Yeah.
Yeah.
So this is regarding that optimal separating hyperplane.
Yes.
And I just want to know the intuition behind it. Can you please open that link?
Yeah. So what is your doubt here?
So the mod beta is equal to 1 constraint was removed in equation number 4.46.
Yes.
So I did not understand how did they do it. And then they assume it for the equation number 4.48, they assume mod beta is equal to 1 by m. So again I didn't get it. What's going on?
Okay, let me say this for a minute. So in the 4.46, so in the 4.46 what they are doing is that, so initially in 4.45 they assume that the beta is normalized vector, so the norm of beta is 1 they have taken, and in 4.46, so this constant is basically the yi into xi transpose beta plus beta 0. This is nothing but the distance of the separating hyperplane or the straight line from the point xi, isn't it?
Correct.
So if the distance is actually this thing divided by this mod of beta, So if we just this is just geometry, using 3D geometry or vector geometry, you can find out that the distance between a straight line given by the x transpose beta plus beta 0 equals 0 from this point to some point xi, it will be y, this thing yi into xi transpose beta plus beta 0 divided by this norm of beta. So if in this 4.46 they have removed it by introducing this factor, so actual distance is divided by beta.
Okay, okay. So
Actual distance in geometrically this is divided by, because beta can be any value. So you can find it, so you can, using simple geometry, you can find out that from a straight line to a point, the distance is given by this thing divided by norm of beta.
yeah, but then so how does it solve the problem of assuming mod of beta is equals to 1? I mean, sorry, norm of beta equals to 1.
So initially started with norm of beta equals 1, then it removed it by introducing this beta 1 divided by norm of beta. So now the, yes,
So the norm of beta is still 1.
norm of beta is not 1 in the, after you, yeah, it is 1 because you can simply replace this denominator by 1, norm of beta in the denominator. It is, if you just make it 1, it makes no difference.
Correct. Yeah. So until 4.47 it is clear. But then again they are assuming norm of beta is equal to 1 by m. We have already assumed norm of beta as 1. Then again they are assuming it as 1 by m. So this is confusing.
Okay, so yeah, 4.46 is fine. Then equivalent to this are positively scaled multiples satisfies them too. We can arbitrarily set norm of beta is 1 by m. Okay, so in 4.46 it removed the constraint that norm of beta is 1, and in 4.45 we can then in this 4 then in the 4.48, so what they are trying to do is that we can set the norm value to anything, because this is just a vector. The magnitude of the vector doesn't really matter to us, isn't it? The beta just gives me the direction, isn't it, of the hyperplane. We first set it to 1, then we removed it, and then we are setting it to 1 by capital M. This magnitude of the vector doesn't really matter in case of optimal hyperplane. We can set it to anything as our convenience, isn't it? Initially we set it to 1, now we are setting it to 1 by M, so that this M factor goes out.
So I just wanted to understand, I mean, how the left hand side still is greater than equal to the right hand side after replacing beta is equal to 1 by m.
So if beta equals 1 by m, so in 4.47 you just plug in beta equal 4.47, you plug in this beta equals 1 by m.
Correct. But I don't understand the intuition behind it, because
So we are trying to remove m from the constant. We just want this beta to remain there, not m.
Exactly. But if you see in the 4.47 equation 4.47, the left hand side represents a it's a number, right? It's a number,
Yes.
real number. And if some real number is greater than some other real number,
Yeah.
and then we are replacing mod beta again by 1 by m.
Yeah, mod beta doesn't really matter to us. We can set mod beta to some anything, so that our calculation becomes easier. So that is why we are replacing it by 1 by m, so that m is no more in the constraints or even the objective.
So doesn't it implies that m is equal to 1? Because mod of beta is equal
Yeah,
to
you
1.
can set beta in such a way that the margin is always 1. M is the margin, so we can represent, we can try to formulate the problem in such a way that the margin remains always 1. This is the case. In case of SBM, if you see that we try to take the margin to be 1.
Okay.
So the distance of the hyperplane from the closest point is always 1. We try to scale the beta in such a way that it happens that the margin is always 1. Yeah, this is how we formulate SVM.
Yeah, so it is safe to assume, right? We did it to make the margin 1.
Yeah, margin becomes 1. So we try to make the margin 1, that is the distance from the closest point to the hyperplane is 1, and based on that we are scaling beta in such a way that the margin becomes 1. Yeah.
Okay. Yeah.
Yeah, this is what has been done. Yeah, it is a little complicated, this formulation. Yeah, but this is the main motive, I think.
Correct. Yeah. On the other websites, they directly assume it. Here they have taken different route.
Yeah, they have tried it in a different way. Yeah, you can also in some books also you will find that m, they have assumed m to be 1, and that way it becomes possibly little easier. I don't know, it might happen little easier, but here they tried to work with m only and then replaced m by 1 by beta. So a different path they have taken for the same thing. Yeah.
Yeah. Right.
Yeah.
Thank you.
Okay. So does anyone have any other questions or doubts? Okay, so if there are no more questions and doubts, so thank you everyone. I will close this meeting. So thank you everyone for joining this meeting. I'm ending this meeting now.